Hey friends, hope you're doing well. Today we're going to start wrapping up our picture or our story about motion. When we left school last time, the story so far, we had talked about position, which is where you are. We had talked about speed, which is how fast you're moving. And we had talked about velocity, which is how fast you're moving and in what direction. So speed is just how fast you're going. That's the number you'd see on your speedometer in your car. And then velocity is how fast you're going and in what direction. So if you have a compass in your car, that tells you the direction. So what about when velocity changes? This is sort of the last piece of the motion picture that we need to talk about, and that is acceleration. Acceleration describes how fast your velocity is changing. So you could be speeding up, like this little guy is doing when the light turns green. You could be slowing down, like this little guy in the red car is doing when the light turns red. Or you could be changing direction. This one tends to confuse people because how could you be driving along at 25 miles per hour at a constant speed and be accelerating? Well, if you're going around a curve, if you notice this little velocity vector down here, initially it starts out pointing straight down and then it swings over to the left. Well, it's changing. So that means you're accelerating. We're going to focus mostly on speeding up and slowing down in terms of our calculations, at least. But be aware if you're changing direction, that also is acceleration. So let's talk about first if you're speeding up. So when you're speeding up, your velocity increases, it gets bigger. And specifically, it gets bigger by whatever this amount A, your acceleration is each second. So if we look at this little animation here, you see this car initially starts out at a velocity of 0. And then if you watch, this velocity number is going up over time. Okay, so in this case, it's going to reset in just a second. So it starts out with an acceleration of 1 meter per second per second. So after 1 second, I've increased to 1 meter per second. And then after 2 seconds to 2, and after 3 seconds to 3. So that number, that 1 meter per second, that is the value that I add to my velocity each second when I'm accelerating. Okay? So let's do a couple examples. This should help you with your homework, hopefully. So let's say I start out with a velocity of 0 meters per second, and I have an acceleration of 5 meters per second each second. Well, what that means is that if I start at 0, after 1 second has passed, I'm going to add 5 to that value. So that gives me a new velocity of 5 meters per second. After 1 more second, I'm going to add another 5, which brings me to 10 meters per second. And then after 1 more second, I'm going to add 5 again, which brings me up to 15 meters per second. Okay, what about if I start with some speed that's not 0? So I'm not initially starting from rest, and I have an acceleration of 3 meters per second each second. Well, now at time 0, I'm just going to start at 4. And then, same thing though, I'm going to add 3 to that value each second. So 4 plus 3 is 7. After the next second, I add another 3, and then another 3, so that my velocity is increasing by 3 meters per second each second. So hopefully you see the pattern. So what about what happened at the end of that animation? That was kind of weird. You saw that all of a sudden this velocity vector flipped around to the left, and now this number is negative. Well, what does that mean? Well, a negative acceleration means that the acceleration is pointing in the opposite direction to the direction that you're moving. And the effect that has is it makes you slow down. It makes your velocity decrease. Okay, so I have another little simulation to show this hopefully a little more clearly. So this guy is starting out at a velocity of 6 meters per second, and he has an acceleration of -1 meters per second per second. So if I press play, you should see he's going to start moving to the right, and over time, he will be going slower and slower. It's a little hard to tell, but you can also watch this number here and you see that the velocity is going down. And now you can definitely tell that he's coming to a stop. So he's slowing down. Okay. So I have a second video that kind of analyzes this. So this second video is a playback. So I'm starting out at 6 meters per second, and I have an acceleration of -1 meter per second per second. So if I play this, hopefully you'll be able to see. At 0, I start at 6 meters per second, and then after 1 second, I've dropped down to 5. And then after 1 more second, the velocity has dropped down to 4. And then at 3 seconds, it's dropped down to 3. So that negative acceleration is just the number that you subtract from your velocity each second. Okay, so let's do one example with a negative acceleration. So let's say I start out at 12 meters per second, and my acceleration this time is -2 meters per second each second. Okay, so I start out at 12, and then after 1 second passes, I'm now going 2 meters per second slower, which brings me down to 10. And then after 2 more seconds, I'm now going at 8 meters per second. And similarly, after 1 more second, I've slowed down 2 more meters per second to 6 meters per second. Okay? So let's put it all together. If an object's velocity is changing, that means it's accelerating, however its velocity is changing. Quantitatively, the acceleration is how much that velocity is changing each second. You can have a positive acceleration, in which case you're speeding up, and then you add that number to your velocity each second. You can have a negative acceleration, in which case you're slowing down, and then you subtract that number from your velocity each second. Okay? So that is all. Thanks so much for watching. Hope you have a good day.